This week we have a Fender repop, and all I know is it has a power issue. I'll discover it myself and see what that power issue is, and it's probably not going to be by plugging it into a wall and seeing what happens. So let's get started. So this is a Blues Deluxe model for those wondering, Type PR246 something, I believe. Not a big fan of repops, but we're going to see what we can do with this. I'm going to take off this back cover. We're going to get inside. Yeah, I'm not gonna lie, opening this up and seeing this in a Fender tube amplifier and working on this, I feel dirty inside. I'm gonna see what I could do anyway. Power supply problem. This was made in '93, so it's old enough to be problematic. At the very same time, it's new enough to be problematic because around this time there were problems with batches of capacitors. Could have caused this issue. This does have solid state rectification. So it shouldn't be too much trouble to see if there are issues. The capacitors are exposed right here. We see a lot of them over here. Two of them are radially mounted. A little problematic to test those. But I think that if we're going to have issues, we're probably going to see them on these. I think the first thing I could do, it's been sitting a while. I'm gonna hook up my meter and just see if I could get a reading off of them right off the get-go. I'll point out that the fuse that I pulled from here looks good, so they either replaced the fuse or it's not blowing fuses. Not knowing what the problem is, I'm just going to have to make some guesses right now. Do a quick visual inspection of the ends of the capacitors. Just want to make sure they're not... maybe. No, maybe it's okay. I don't know. These are okay. These perforations will blow out right here. There's a problem. Let's get the meter up on this one. Let's see what we got. First one's reading real good at 106 microfarads. I'm going to jump to the one under it. That second one has a good reading at about 98 and change. The remaining capacitors were all on the money, or they were really close, so I didn't find any issues with the capacitance. Haven't read the leak down, but as far as capacitors, I didn't find anything nuts. What I'm going to do is I'm going to bring this amp up really slowly, and I'm going to monitor current. If I see anything wrong, I'm going to shut it down. Anything at all. I'm going to bring all these knobs to 0 and fire it up. So I just have a trickle voltage. I'm going to keep it in standby. See, 200 milliamps just on starting it up. 70, still at 200 milliamps, 13 watts. We got enough electricity now to make the pilot turn on, and now we're pulling a little bit of power, 22 watts. I'm going to take it to 100. Just keep it just a little low at 24 watts. I want to take a look at the actual voltage. We're at 300 milliamps, absolutely nothing, no power. 115 is 35. So now that I know that the standby is 36 watts, I've now taken it out of standby, and the tubes have heated up. I've shut it off, and I'm slowly going to dial it back up again. And I'm going to make sure that we don't have excessive draw. We're 400 milliamps, 100 volts. So about 110 volts at half an amp. So everything seems fine. 120 volts, 63 watts, 570 milliamps. So that seems fine. Let's read off these capacitors. 423, 424, that seems okay. 211, 203, 382, all of which had nothing but standby was on. 348. You're gonna have to get a voltage chart for this amp. Make sure all these voltages are correct. But I'm not seeing any issues with current, not seeing any issues in general. I might be wrong, but it's worth noting as an observation that this thermistor looks cracked in half, right? TH1 over here. I'll be looking at that more closely. Right now the amp's powered up, but I saw that. How about that? So I'm just going through the functions on the top of this amplifier to see what's what here. And there's two inputs, bright switch, drive select, regular volume. Got the guitar on the wall. And the pots are dirty, right? No doubt. That's not good. This bass one is terrible. Wow. I'm going to throw the tubes from this amplifier up on the tester here, check them out, make sure that they are okay, and then also give them a little bit of a tap and make sure there's not any mechanical problems with the tubes that may be causing an electrical issue that might be masked on the bench. Going to do that now and report back any findings that I have. So for all the 12AX7s tested really good, and there are no shorts, and tapping it didn't introduce any shorts or problems. We're going to test the 6L6s now. Yeah, I don't see any obvious mechanical problems with these tubes. They seem to be operating just fine. So I'm going to say that they're okay. We're going to move right to testing all the electrical test points on this amp. Before I go any further, though, I'm going to be getting in all of these pots and hitting it with deoxit. As shown before, each and every one of them is cruddy. None of them work right. And luckily, there is a provision in each of them to get in there and spray some deoxit in there, so I can do that now. And there is a problem with this amp. It took a while to reveal itself. It just happened to work perfectly the first time I was working with it. We hear noise, right? There's definitely something in there, and I could trace out the noise relatively quick. It may point me towards the problem, but this is what I want to show you. This is interesting. Watch this. You ready? It's dead. It's dead. Like, you overpower it, there's nothing. And obviously I want to check some voltages and see what I got right there. And I can sit here for a couple minutes. It's almost as if the standby switch is on, right? There's nothing coming out of this. Come right up to the speaker. Got nothing. And then just like that, it could clear up and turn on, start making that noise again, right? So what I'm going to do is I'm going to get it going first, right? And then I want to see what stage that garbage is coming out of, right? See if I can isolate it, see what's going on and what's causing that. That's probably the electrical issue that the guy was talking about. There's no problem with the electric of this amp, but there's a problem with this amp. I'll point out too, sometimes I could get it to come back if I sort of jump start it. Watch this, you ready? And there it is. So I want to see where that noise is. We're going to go through schematic, we're going to trace this out. Taking the speaker out of circuit, and I've added my 8 ohm 100 watt brick, and in turn I have my Heathkit signal tracer, and we're going to be going through the circuit, especially to isolate that sound that we've been hearing. So I'm going to give it a little bit of volume, and we're going to just go through each stage one at a time. So right out the gates, the first section, awfully noisy, right? This before volume, so none of the controls have any function on this, but I'm hearing a lot of noise. More importantly though, right? This is not, there's no cutout, no matter what I do here. So this section, not only is there noise right here, but this section is not being affected by that cutout issue. So I'm curious, I just want to swap the tubes between 1 and 2 and see if the noise is in the tube itself. That could be a quick kill. Wow, that is a big difference on the first stage. Night and day. We got a bad tube. So much so that I've got to replay this again. I got to do before and after. Stand by. This is really awkward for me, so I'm going to set this up really quick. Here's the before. This pin 1. Now I'm going to swap and do an after. Here's an after. That is so much cleaner. But all I did was pass the buck, so I'm going to have to temporarily replace one of my 12AX7s and move on. When the condition happens, this LED turns on even if the drive select is not in. The light turns on. I could hear a relay clicking as it happens, right? And what I was able to get at this time is that it works through the second tube, V2A. V2B is just wired like this to nowhere, right? But V2A is still good, so it makes it out of V2A even in that condition, and I haven't tested further. I think maybe we're close to this relay right here, maybe causing some sort of issue around here. So I'm going to test further, maybe somewhere in the solid state circuitry. It's possible. I got to tell you, it's a strange project when you see me working on a Fender tube amplifier and I'm reading the measurements off of op amps with a DSO oscilloscope. But such as it is, This is what we're working with. And what I got here, there's some background noise because this is a floating input right now for the purpose of this test. And coming off of V2A on pin 1, we find ourselves meeting here at least electrically on the output of this op amp on pin 7. So I thought I'd take a look at pin 7 and see what's on there. Right now, as it stands, 15 volts. And I wanted to see what the output of that op amp was during the time that this situation occurred. And it just occurred right now, just like that. And we could see that it has flipped by itself. And I'll see if I stay here. The light is on, right? This LED is illuminated. And it's flipped over. There's no noise coming out of it. And when it goes back and the speaker is making noise again, it should drop back down to negative 15 volts. I could probably make it drop back down. Ooh, I might have just found it right here. Check this out. There it is. Got a bad resistor. Now I have to find out if it is the resistor itself or if it is the solder joint. I'm sure these things get awfully hot. No doubt after a time it loses connectivity in there or fatigue internally. So what it was doing, it was causing all sorts of havoc in here, affecting the electric for the op amp, for the relays, and what have you. So yeah, I guess that's not out of the realms of possibility. Let's see what we got here. Oh yeah, so these would be the resistors for the 16 volt rails over here. That neg 16 right over here would feed the relays, as would appear. Looky here at RY2. So if that resistor would cause any issue and there were fatigue, it would cause issues for those relays over there, as well as the power for every single op amp in this circuit, right? It would basically cause calamity, right? If there were problems with those 5-watt resistors, right? So it's worth inspecting those resistors specifically to see if there are any issues. I'm going to turn this back on, and I'm going to want to read the voltage drop across this resistor. Obviously, I can't read the resistance while the amplifier is running, but I can see the voltage drop. So I've got my Heathkit IM11 hooked up, and when I fire up this amp, we're going to take a look at that voltage. We're going to play with that resistor slightly, and we're going to see what happens. We're going to start messing with those resistors in just a minute. Once the amplifier heats up, I'll give it a bit. We'll get a good look at the voltage drop. Let me grab an implement. Okay, and here we go. Yeah, look at that. I'll back away so we can see what I'm doing here. Try and get it all in frame. It's possible. It's hard to say. We could definitely see that voltage swings quite a bit. Try and push upward. Yeah, see that? Look at that. Another thing I noticed during my inspection was that when I was using the plastic device to touch these bundle of wires here and push them, I was hearing an audible sound coming from the speaker. Sometimes this light, you could see it flicker ever so slightly. What I did was, shutting it down, each one of these connections was removed and then reconnected. The metal sort of bites back into the metal, making for a nice clean connection, removing the oxidization from the metal. Did that with each and every one of them until I was able to see that when I turned it back on and was able to push it again and disturb it, there was no audible sound coming through and the light was no longer flickering. So that was another issue that I was able to resolve. So I want to talk about my plan right quick. I'm hoping to take this circuit board here, this main board, pull it down, fold it outward, exposing the areas I'm going to make repairs on. That's going to be these two resistors right here, as well as this component right here, TH1, the thermistor. This means that all of these connections, all of the potentiometers, and these connections will have to be removed from this top piece of the unit. See, these jacks are actually plastic here, and they float, which will make it easier for this to remove. All the knobs will open with the flathead set screw here. A little loosen, pull them right off. Then these will have to be loosened. Now I'm going to remove some of these Phillips screws that are holding the circuit board. See one in the bottom corner here. There's also one over here. There are others. Take them all out now. With the screws removed, we can see that the board is now falling. This is a good sign. It means I'll be able to pull this down and hopefully outward without disconnecting too much. I will disconnect what's necessary though. Looks like the only thing to be removed is the standby cables right here. And that's it. That's all she wrote. Let's take a look. And this is the first time that we are able to see what the back of those two resistors look like. And we could see that that board has seen some heat. But what I want to do is get a close-up look. We're going to wiggle that. I think I see a cold solder joint. Let's get a nice close-up look. Let me put this in the stabilizer. None of these solder joints look good, especially this one right here. It's hard to say. I do know that when I touch the thing, I see a definite reaction, so it could be the resistor as well, but the solder joints themselves look bad. There are a couple other ones here that I really don't like. I'm probably going to reflow a couple around here, but just look how this looks right here. This has seen some better days. And the thermistor that I was talking about before, and I'll show you the condition when I pull it out. Look at the soldering job on this thing. It doesn't really look like any other soldering job on this board. It wasn't cleaned up, and we could see all this left behind. It makes me wonder if the thermistor had been replaced at some point and it wasn't put in well. It looked, maybe there was too much stress exerted on it when it's put in, because they do heat up a lot. And if you tie them down really tight, you get a lot of thermal stress, and eventually they crack in half in the board. There has to be a little bit of slack on the leads when they're placed in. That may be the case for this, and that's why that failed. What I'm gonna do, having received the parts for replacement, is I'm just going to initially just replace the parts that need replacing. That's the two resistors right here and the thermistor. And then I'm going to go through with the magnifying glass and shore up any areas that I think are shallow or have bad solder points. Once the solder is removed, each of the resistors has a small amount of hot glue suspending it off the board, so a razor blade will be used behind it to score that glue off to remove the resistor. Here we have the first of the two resistors, and then the second. These two read 423 and 508 out of circuit. The replacements read 476 and 472. I've given the new resistors a greater margin off the board, about 1/2 centimeter. I want to make sure that it's aligned and straightened on the board as I install it. Next, we're going to focus our attention on the thermistor over here. Here's the new one that'll be going in. Okay, now I'm just going to be doing some touch-up work in some areas that I don't like, where the solder looks a bit shallow. Now we're going to roll the amp back up in the operating position. I'm going to point out that the dioxide I put in these connectors, when I sprayed them in, with it hanging upside down, worked its way all the way down. These are all nice and smooth now, like brand new. But we'll roll it this way. It just needs to be, wire just needs to be pressed down a bit, just to clear that area. I flipped the board back up, I reconnected the standby, and I put one screw through just to stabilize everything. Made sure that all the potentiometers were back in the zero position. And I'm probably going to put one more screw through just to stabilize it. And then what I'm going to do is I'm going to do a smoke test on the Variac, make sure the work was good. But I just want to show what work was done real quick. See, here's the two resistors that have been replaced, and they now stand off further from the board, so they don't heat up the circuit board as much as before. And we can see way down there, TH1, the thermistor has been replaced. Beginning the smoke test now. I am going to bring it up out of standby, but right now I wanted all the tubes to warm up before I shut it down and start to cycle again like I did before. So we're going to 120, 40 watts, 350 milliamps. So I'm going to shut this down, bring my Variac to zero. And the reason why I do this is because if there's a problem on the high voltage circuit, I don't want any surprises when I flip the switch. I want to see if it comes up slowly. So while the tubes are hot, and I haven't replaced my 12AX7 yet. 120 volts, 62 watts, 1/2 amp, or 570 milliamps. Let this cook for just a little bit. There's no more noise, no more artifacts, no more nothing coming out of this amp. The power supply is solid now. I think it's time to put this amplifier back together. Got all the screws back in the main board. Got all the little screws and washers and whatnot back assembled. Since there's no way to screw down a chicken head in positions 1 or 12, I'm going to put a small dot in the representation of 1. And I could just dial them to 6. Lock it down right there. There we go. Right at 1. Right at 12. That one's done. Oh, right on the money. 12-1. Do this until I get tired of it and then do 3 more. And before I close the cover on this project, I'm going to be replacing my tube that I've swapped in here temporarily with this new Tungsol 12AX7. This cover did not come off without a fight. It's probably not going to go on without one either. There it goes. Now I'm going to take this out as standby for my angry quality control department. Whoa. Bring up the volume some. Doesn't take much. Wow. Roxy. Roxy, you fan? That's fantastic.
What?
Good job. And for those who've been watching this, I hope you enjoyed the repair of this. What is this repop? I don't even know. This is a Fender Blues Deluxe. So thanks for watching.
Thanks for watching.